Hello class. In this video I'm going to give you the solutions to the 1.7, 1.8 handout. So this handout has us solve systems of equations. Remember, a system is two equations that we're going to try and solve simultaneously. So you'll see here's equation 1, equation 2. We're going to use the elimination method. Some books also call this the addition method because we're going to add these two equations together and hopefully eliminate either x or y. So the first step says arrange the equations so that like terms line up. That just means on the left side of my equal sign, I want to have an x and a y, and I'd like them to be over one another. So you'll notice on my first equation, the y is on the right side of the equal sign. So I'd like to move this y to the left side of my equal sign so that my terms line up. So if I add a positive 3 to both sides of the first equation, you'll notice the negative 3 plus 3 will give you 0, right? So negative 3y plus 3y would give you 0 on the right side. And then on the left side, we would add the plus 3y to have 4x plus 3y. All right, so I just rewrote my first equation. I didn't touch the bottom equation. And now when I rewrite the first equation and put it over my second equation, you'll notice that we fulfilled the obligation of step 1. Right? Arrange the equations so like terms line up. The 4x and the 1x have lined up. The 3y and the negative 2y have lined up. So step 1 is done. Step 2, as needed, multiply one or both equations by numbers that make opposite coefficients. All right, so my coefficient here is 4 and 1, right, for the x. 4x, 1x, so the coefficients are 4 and 1. So if I multiply the bottom equation by negative 4, that will give me opposite coefficients, right? If I multiply, and remember, you have to multiply each term by this negative 4. So when I multiply the bottom equation by negative 4, I end up with negative 4x. Negative 2y times negative 4 will give me positive 8y, and 13 times negative 4 will give me negative 52. The top equation I did not touch. I just rewrote that over here. Now, the third step says add the equations to eliminate one variable, right? That's why it's called the elimination method or the addition method, right? So if I add these two equations together, right, here's my new system. We add the equations. Well, the 4x and negative 4x will disappear, right? That's going to give me a 0. 3y plus 8y is 11y. 8 plus negative 52 is negative 44. Divide both sides by 11, and we end up with y equals negative 4. Now, you might be tempted to pat yourself on the back and say, yay, I did it. But remember, this is really only half of the answer, right? The answer to a system of equations, really, we're asking what ordered pair is the solution, right? What value of x and y will make this thing true? Okay, so we found the y. To find x, we can take y equals negative 4 and sub it into either of these two equations. It doesn't matter which one. Okay, so looks like I took the bottom equation, the x minus 2y equals 13, and I sub in negative 4 in for y. So you see I do that here. And when we simplify, we get x equals 5. I'd like you to write your solution as an ordered pair, 5 comma negative 4. Okay, so that's the first problem done via the elimination method or the addition method. You'll notice in step 2, I multiplied by negative 4 to eliminate the x's. You could have also multiplied the top by 2 and the bottom by 3 to eliminate the y's, right? We could create 6y by multiplying this whole thing by 2. And we can create negative 6y in the bottom equation by multiplying the whole thing by 3. And when we add the two equations, the y's would disappear. So there's more than one way to handle these problems. The second one. All right, let's solve the system of equations using substitution. Okay, so it says solve one of the equations for one of the unknowns. Okay, so I have 3x minus 4y equals negative 25. I have 2y plus x equals 5. So what they're asking me to do is either get x by itself or y by itself. So I look at the bottom equation, and since x is almost by itself, all I need to do is subtract 2y from both sides, and you'll see x is now by itself. Okay. Step 2 says substitute the expression solved for in step 1 into the other equation. So Now that I know that x is equal to this 5 minus 2y, right? X equals 5 minus 2y. I can circle the 5 minus 2y, right? Because x is equal to everything I just circled. So I could take everything I've just circled and replace that or place that into x. So instead of 3x, I just wrote 3 open parentheses, close parentheses, and I'm going to drop what I've just circled into these open parentheses. All right, so you'll notice this is the first equation. I'm replacing the x with everything I've just circled. And you'll notice all of the x's are gone. So when I distribute the 3 and simplify, I end up with y equals 4. Again, this is only half of the answer. If I know y equals 4, I can replace y with 4. All right, so instead of 2y, I write 2 open parentheses, and then I drop the 4 into the parentheses. And you see I end up with x equals -3. So my ordered pair is -3, 4. Now some folks say, hey, where did this equation come from? Remember, that was the original equation, okay? So that's the substitution method. And then the last one is solved by graphing. So here's a system of equations. We can graph these into or enter this into our graphing calculator, but the bottom equation is fine. We can enter this into our calculator, but the top equation is in x. So I have to rewrite this equation so in terms of y. Okay, so you'll notice I add positive y to both sides to get rid of the negative y on this side. And then I end up subtracting x from both sides. And now you'll see I have y equals 3 minus x. So I can graph y equals 3 minus x. So let me open up my calculator. Okay, so here's my calculator. I press y equals. And now notice my plot is still on. So the last problem I did was probably a regression equation where I did a scatter plot. If you're not going to be doing a scatter plot, you really want to make sure you turn this off. So I press up arrow, enter, and then down arrow, okay? So when you're working, you want to make sure that your plot 1, plot 2, and plot 3 are off, right? This indicates that my plot 1 is on. I don't want that because I'm not doing regression or a scatter plot. So I press the up arrow, I press enter, I press the down arrow, I press clear. Now we can begin. So the first equation we want to graph is this y equals 3 minus x. So I press, well, the y's done for us, 3 minus x, right? That was the newly written first equation. The second equation was y equals x plus 1. So here's x plus 1. So now we've graphed the two equations. Again, why did we have to rewrite this equation? Because my calculator starts with y equals. So I had to rewrite this to get y equals. So after rewriting, we have y equals 3 minus x. Now, my window, right, this is my previous problem. I can manually type in -10, +10, but a quick way to go about redoing our window is if you press the zoom key, number 6 as standard. I only do that when the numbers are small, 3, 1. Usually that will fit on a 10 by 10 window. And there's my graph. And I just want to press the window just to show you what the effect of pressing zoom and 6 did. See how my new window says 10, -10 to 10, -10 to 10. That's our standard window. So the solution to this system is the intersection. So if I press the second key, the trace key, number 5 for intersection, and then I press enter, 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 that's my intersection. Okay, so how will you record your answer on a test? I would want you to actually sketch a graph and label the point. Okay, so on a test, I'm pretty sure I'm going to ask you to solve a system of equations by graphing. So you're going to have to enter the two equations into your calculator. You're going to press second, trace, number 5, enter 3 times, and there's my intersection. So I'd want you to actually, it doesn't have to be a Picasso, but I'd like you to hand draw this graph. And at this point, you're going to write in as an ordered pair 1, 2. Okay? Thank you for watching. I hope this helped.